In this lesson we are going to review previous assignment, make our ball react to physics forces, and set up super bouncy physics material. Previously in the assignment I have asked you to build level based on the reference. Now I will walk you through the steps of level creation. First of all, let's make sure that our ball has scale and position reset. In the game view, you will notice that ball is not precisely centered. This happened because default camera which was created together with a scene is a little bit above the ground. That's why I will make sure that camera is positioned at 0 on y-axis. This will place the ball perfectly in the middle of the screen. I will also move camera further away from the ball. I'm happy with the way everything looks with camera at -20 on z-axis value. I rename sphere to ball. To create walls, I will use cube as a starting point. Reset its transform and move wall to the upper part of the screen. 11 on y works well in this case. Time to stretch my wall along x-axis. Rename my cube to border upper and make a copy, which I will name to border lower. Move it to -11.5. To create gates, I will make copy of border and reset its position. Rotate 90 degrees on z-axis and move to the left side of the screen. Adjust scales to your liking. Time to make gates material, which I will make of orange color. Make copy of gate and move to the opposite part of the screen. X value of 17 works well here. For players' rackets, I will create brand new cube and reset its transform. Set X scale to 0.5 and increase Y scale to 2. Make a copy, move it up and rotate 15 degrees on Z-axis. I will disable background in scene view so that I can see things a little more clearly, and will also switch viewport camera to orthographic mode by pressing on this area here. This way I will see my items without perspective deformation. To exit orthographic view mode, just press on this area again. Duplicate the cube again and move down. We have to invert rotation value to -15 degrees. Let's create empty game object and parent 3 cubes we prepared earlier under player 1 game object. Let's make sure that all objects have Z position at 0. This is super important. Now I will make a copy of player racket, move it to the right part of the screen, and rotate 180 degrees on y-axis. Now we are ready to proceed with the lesson. In our Pong game, idea is that ball is moving across the field and bouncing off the walls and player rackets. Each of the players will score if ball goes through the enemy gates. To make ball flying and bouncing, we are going to use Unity physics. First of all, let's run our game and see how things are looking at this moment. Nothing is happening. Ball is hanging in the air. And the plan is to give impulse to our ball so that it moves and bounces off walls. Select our ball, press Add Component button and choose Rigid Body. Now let's run our game. You can see how ball falls, but it's stopped by the lower border. The ball is falling because it is affected by gravity. Both our ball and border have collider components. That's why when ball hits border, it doesn't go through. Any game object which has collider and has no rigid body will be treated by Unity as static. Something that doesn't move or is not supposed to ever move. Now please pay attention to a very important rule. If you have a moving object which has a collider, then it is a must to add a rigid body component to it. Unity will have to update collider data every frame static object is moved, and that will cause significant performance loss. So if your object has collider and will be moving, add a rigid body to it. Notice that border has box collider, but ball has a sphere collider. You can add as many colliders as you want by using Add Component feature. Colliders are drawn as green wireframe in the viewport, and you can tweak them to your liking. To do that, you can type in values directly in the fields or enable collider editing mode by pressing this button. Now, if you click and drag green points, you will adjust collider size. In case of sphere collider, you can adjust its position and radius. Sphere collider is the fastest for Unity to compute, so if possible, use sphere colliders. One more interesting collider is a capsule. Here you can tweak radius, axis and length. Very useful if you're working with character limbs or something long and round. Whenever there is a collision, we can track this event and use its data later. In case we still want to register collision, but want our ball to fly through, we need to change collider to become a trigger. This will be the case when ball goes through gates and scores a goal. For example, if I select border and set is trigger, you can see that ball falls through. In Unity, this event will be still registered, but instead of actual collision, we will get overlap data. So whenever such overlapping took place, we can ask ball which object it was inside of. We will use trigger type of collider on both our gates. So I will stop game and change gate colliders to become triggers. See you in the part B.